Hello everyone. Today, me and Harsha are going to present on sentiment analysis of review datasets using Naïve and the KNN classifier. So, what our paper is trying to do is classify sentiments as positive, the product reviews and user comments testimonials into positive or negative, and find out the general sense about our product. This is being done using two popular machine learning algorithms known as k-nearest neighbors and the naive Bayes. Sentiment mining is very important to find out how our company is doing and what the world feels about our product. The sentiment found within reviews provides useful indicators for many different purposes and can be categorized by polarity. By polarity, we tend to find out if the review is overall a positive or a negative one. So if the sentence were consist words like loud, it would probably mean a positive comment, whereas lunchbox is a flop movie, which consists of the word flop, would probably mean that this is a negative comment, and this is being done automatically by our algorithms. So it is widely used commercially to find out what the company is dealing with in terms of customer reviews, the tracking of users and non-user opinions, and rating on product and services, the monitoring issues of confronting the company as to prevent viral effects, and assessing the market buzz about the company and the latest trends, fads, and fashion. So the proposed work, here we're using two classifiers, the neighbor-based classifier and the k-nearest neighbors classifier. Two data sets are being considered, the movie reviews and hotel reviews. Movie reviews are from imdb.com and hotel reviews from Open Review Rank dataset, and it is composed of 5,000 of positive and 5,000 negative each. So the Naïve classifier. This classifier is very famous as and this is mainly because of its considered assumption of independence. It has 5 steps where data is collected, then the text is prepared, and the sentiment is detected. This is then the sentiment is then classified, and the presentation of data, which would give us the final output. So maybe this was introduced for text categorizing and the problem of judging documents belonging to one category or the other, initially by word frequencies. So this requires a very small training data set, and that's the best part about it. And it uses the conditional probability model, and despite it being very simple, it has proven to give very good results. So coming to the technique, it is based on the assumption of word independence, and the starting point in Bayes' theorem for conditional probability stating for each given data point x in class C would be given by this formula. Next, the algorithm being used here, the input is the document and all the classes where we want to classify our data points. So the steps involved would first include the pre-processing, where 10,000 reviews are taken from IMDb and then they are divided into positive and negative. Each are kept in two empty lists are created, one for the positive ones and other for negative. The sentences of positive review are broken and the POS and NEG tags are appended to it. Then the sentences are divided by as 3/4 and 1/4, where 3/4 of the sentence are kept for training and the rest is kept for testing. Then the chi-square test is applied and scored for each of the remaining words. And instead of using all those words, we only use the best 10,000 words. The classifier was trained using the dataset just prepared. The labeled sentences are kept correctly in referencing sets and the predicatively labeled versions. Metrics are calculated accordingly. Here is the flowchart of the naive Bayes, where the reviews are split into positive and positive are appended with the POS tag, negative with the NEG tag. So 3/4 are kept in the dictionary, whereas 1/4 are kept for testing. Then the parts of speech tags are added to each, and the nouns and verbs are discarded. And conditional probabilities is found, and the best keywords are taken for the adjectives, which is given to the NV classifier, which is Naïve classifier, and applied on the 1/4 testing dataset, and we get the output. The complications with the k nearest neighbor will be discussed by Harsha.
Hello guys, this is Harsha, and in this part of the video we talk about the KNN classifier, or the k-nearest neighbor classifier. KNN is a type of instant-based learning or lazy learning algorithm where the function is only approximated locally and all the computations are stopped until all the classifications are done. In case of classification, the output is class membership. The object is classified by majority vote of its neighbors, with the object being assigned to the class most common among its k neighbors. The KNN is a rather easy algorithm to understand and implement, and a powerful tool which we have at our disposal for sentiment analysis. KNN is powerful because it does not assume anything about the data other than the distance measured that can be calculated consistently between two instances of the same data. It is also called non-parametric and non-linear, as it does not assume anything about the functional formation also. And coming to the algorithm of KNN, in the pre-processing steps, we retrieve about 10,000 reviews from imdb.com/openrank, which is a review dataset. Of those 10,000, 5,000 of them are positive and 5,000 of them are negative. And we keep them in two files, pos.txt and neg.txt. Two empty lists were also taken in the next step, one for positive and one for negative reviews. Sentences of the positive and negative reviews were broken into POS and NEG tags and were appended to each accordingly and were stored in two empty lists created in the previous step. 3/4 of these sentences were kept in the dictionary for training purposes, and the remaining were kept for testing. Coming to the training of the dataset, we use a particular chi-square test, in which we calculate the score of each of the words occurring in training dataset. An empty list is created, the dictionary in which the words from training dataset are stored, followed by each of the scores, and thus calculated. For each word in each test review, if the word exists in the word score list, we add its score to the review score. Else, if we find the word in the word score list with minimum Jaccard index to the unknown word or unknown sample, and find its score to the review score, and that is how we find the metrics accordingly. This is the flowchart of the same algorithm which was explained in the previous slides. Coming to the chi-square test, we initialize an empty frequency distribution along with an empty conditional frequency distribution also, which is based on words being positive or negative. We fill out the frequency distributions incrementing the counter of each word within the appropriate distribution. We find the highest information features, which is the count of words in positive reviews, words in negative reviews, and words in total. We use a chi-square test to score the words. We find each word's positive information score and negative information score, add them up, and fill up a dictionary correlating the words and scores, which we then return out of the function. This test is based on LLTK, which is the natural language toolkit, and is performed using several other commercial data mining tools such as SAS, SPSS, Oracle Data Miner, and SQL SAS, with the help of techniques such as variable clustering and variance inflation factor, which can be found in SAS, and interesting mix factor in SQL SAS. Coming to the experimental results, these are based on three parameters: accuracy, precision, and recall, which are the methods used for evaluating the performance of opinion mining. Here, accuracy is the overall accuracy of certain statement models. Recall positive and precision positive are ratio and precision ratio of true positive reviews, and recall negative and precision negative are the ratio and precision ratio for true negative reviews. Accuracy and the other recalls and precisions are found using the confusion table that is given below, which can be self-explanatory. Coming to the results of the model and the test, when we apply both Naïve Bayes and KNN on the movie reviews, Naïve Bayes has an upper hand in giving more accurate results than the KNN. When we apply these both on hotel reviews, we get about same accuracies, but low valued accuracies to be exact. These accuracies are not very precise, and when compared to the movie reviews, and again, it all depends on the data. So that is how I conclude this presentation. Thank you.